Good morning. I'd like to tell you a little bit about who I am and where I come from before I get into the main presentation. I grew up in Denver, Colorado, and I went to the Colorado School of Mines to study engineering. I didn't know what branch I wanted, and I was 3 majors my first year and a half. But I turned out to be a metallurgical engineer. I got a bachelor's of science and master of science in metallurgical engineering from the Colorado School of Mines. My junior year, while I was at Mines, I became a Christian through Campus Crusade for Christ. I wanted to learn more about my faith, so once I graduated from Mines, I went to Denver Seminary, which is part of the Conservative Baptist movement, and got a Master of Arts in Theology. I then went to work for 5 years in a medium-sized steel mill in Mansfield, Ohio, where I also met and married my wife. In 1982, I quit my job, I got married, and I moved to Bryan, Texas to work on a PhD in mechanics and materials at Texas A&M. From there, I went to Louisiana Tech for 20 years in Ruston, Louisiana, and I moved to Baylor 7 years ago. To me, this is a very important topic, looking at the relationship of theology and engineering, because as a practicing engineer and as a practicing Christian, my faith and my profession are important. My faith affects everything that I do, but I must admit the mentality behind what made me an engineer affects everything that I do very well, much and too well. So I need to think about how to relate them together. One of the things is there's not been near as much talk about engineering and faith as there has been in science and faith. So I've gained a great deal about how I relate to engineering as a Christian from looking at how scientists relate their faith. And there's a whole bunch of literature and books and publications about that, and I very much simplified them here. You know, that you can think of science and theology or science and faith as two different worlds that never really intersect at all, except that you may be in both worlds at different points. Kind of a two spheres approach. Some people would say, yeah, I'm both, but science is more fundamental, and if I see any apparent conflicts, obviously science is correct. The opposite is that my faith's more fundamental, and my science must be reinterpreted in the light of my faith. And the last one is that my science and faith are not the same, but their concerns overlap in some complex way. And this last approach is basically how I relate Christianity and my Christian faith and engineering. That they're not the same, but they do overlap in many, often very complex ways. So this presentation looks at one aspect of that, the idea that engineering is an approximation to reality, and that theology is an approximation to reality. In neither case is they the total reality. So I want to look at what is engineering. I'm going to give a different definition of engineering than we heard last night. What is theology, and then some relationships between engineering and theology, and I'll look at a particular example that's been significant, in my opinion, in the world of engineering education. One of the issues is crafting a definition of engineering is not simple for us engineers. I think every discipline has the right and the obligation to define who they are. One of the issues is there are some activities that are clearly the practice of engineering, and there are some that are clearly not the practice of engineering, and there's a lot of activities where it's not really clear whether engineering is being done or not. And the word engineer is used in a lot of different ways. Some people talk about to engineer something means just to create something. You know, and when I grew up, I thought engineers built bridges and drove trains. I don't think the person who drives the train is necessarily an engineer in the way I would think of it, although that person could be. So let's look a little bit more about what is engineering. There's a lot of written definitions of science and the scientific method, but there's been far fewer attempts to define engineering. Many definitions are attempts to define one branch of engineering and how it is different from another. But the problem we face in engineering education is even those attempts are getting vaguer and vaguer. I'm a part of the mechanical engineering department heads community, and we're involved with our accreditation agency, ABET, and part of what we have to do in accreditation is define what you have to do to be a mechanical engineer. Well, twice in the last 10 years we've broadened the definition so it's less obvious what a mechanical engineer is. And when I shared the newest version excuse me, with my faculty this spring, one person says, eventually if we could spell mechanical, we'll be a mechanical engineer. You know, it's not quite that simple, but the point is, we're not even sure what is a mechanical engineer. An example, there's 14 faculty in our mechanical engineering department. 5 of them, including myself, have 0 degrees in mechanical engineering. But we have degrees in some other field that has some relationship to mechanical engineering. So engineers don't even necessarily agree on the boundaries from the disciplines. So having said that, let's try to come up with some definitions. I am indebted to the thinking done by Dr. Billy Keene at the University of Texas. I've heard him speak, but I've never really talked with him. But he's written a little book about the definition of engineering. To understand his definition, you need to look at the term heuristic, which he uses in a very significant way. He says a heuristic is something that's an aid or direction in the solution of a problem, but you can't justify it by itself. An example some of you may use is you have a rule of thumb. Certain things work, certain things don't work, and we really don't know why. And you know, that goes back to my question from last night, that engineering has been around a lot longer than science in the way we usually understand science has been around. People have understood how to make things work without knowing why they work. And engineers still do a lot of things that way, that we don't know exactly why certain things work, but they do, so we use them. Other types of engineering heuristics may be you want to make small changes rather than big changes. Or this last one is an example. If you try to design something and want to get to a perfect design, you're never going to finish. At some point, you've got to say, we're going to freeze the design, and if we have better ideas, that's going to be a next year or next decade's model, but not in this one. So these are things, I can't prove any of them, but engineers use them. So his definition, he says, the engineering method is a strategy for causing the best change in a poorly understood or uncertain situation within the available resources and the use of heuristics. First observation, he doesn't mention science at all in here. But also at the heart of this definition is that engineering is a great deal of approximation. You know, he's talking about the situation is poorly understood, you have some limited resources, and you have some heuristics describing what works, some of which may be based on science, many of which may not be. This is an extremely broad definition of engineering, and it's also a definition of engineering, again, that gets at the approximation nature of engineering. Last month at about this time, I was in Musanze, Rwanda, speaking at the Sunrise School, spelled S-O-N, because it's a Christian school, and for orphans, and we're trying to describe for them what is an engineer. I didn't want to try to give Billy Keene's definition to Rwanda seniors, so this is the definition I used. Engineers turn ideas into useful systems or products. The picture you see here is one of our freshman students of a couple of years ago getting ready to test a truss that they had designed in class. But the idea is engineers are different from science in a variety of ways, but one of them is they create something. You know, another way to look at it is engineers solve problems. But the idea is we're creating something that's useful. Now, useful, it may be a controversial thing at times too, but we're creating something not just for the sake of knowledge, but for the purpose of having an effect upon something else. So engineers use models in their analysis. The problem many of our students face is they think these models are the reality, where in fact these models are attempts to give us a picture of the reality of engineering, of the physical world. An example, Newtonian mechanics, I think that was mentioned at some point by both speakers last night. What Newton came up with is not the reality of the physical world, but it describes a lot of things within the world very, very well. Let me use one that's from my area of composite materials. Lamination theory is a way to predict what happens if you lay up a composite where you have fibers in all sorts of different angles layered on top of each other, and you're trying to predict what would be the mechanical properties in a given direction. When students lay up a composite and do a test, and then the test doesn't match the theory, I've never had a student question the theory. They all say, we must have messed up in the test. Now, given the nature of students, messing up in the test is a very live possibility. But the point is, sometimes they didn't make any mistakes in the test. The machinery was well calibrated, and perhaps the theory might have had a problem, the model. You know, so lamination theory does predict some things well. It predicts some other things not very well. And the point is, students tend to think the theory is the reality, and the experiment is the mistake. And while the experiment can have a mistake, we need to recognize that these various theories of how we predict things are just approximations in themselves. Thank you. This is my 4th conference in the last 9 days, and I think I picked up some allergy issues at the first one in Fort Worth last weekend. I'm sorry. Thank you for the water. Theologians also create models of how to describe how God has acted in human history. I'm not sure if theologians use the term model necessarily, but that's what they have. A classic example is their perspective on end times. Whether you are all-millennial and believe there is no millennium, whether you're premillennial and believe Jesus comes back and establishes the millennium, or whether you believe Jesus comes back at the end of the millennium to culminate history, those are all different models of how the world will end. I don't know for sure. I have my opinion as to which one I like, and you probably do too, but we really don't know for sure at this point because Jesus has not yet come back. So we need to recognize that theologians create models all the time as well. And while these models in both the theological sense and in the engineering sense are abstractions concerning ultimate reality, they need to be precise enough upon which to base fundamental choices in life. When I get on an airplane later today, I'm assuming that the people who designed that airplane from Boeing knew what they were doing. So the importance of this, if we're to experience the life God wants us to have, we need to understand theology well enough to know what God expects of humans. And I'm not going to get into any theological details, but the idea is that we need to understand something about how God interacts with humans if we're to have the life He wants to have. And similarly, in the engineering world, Newtonian mechanics is not a perfect model, but it's good enough to design the airplane that I'm going to get on later today. One of the issues at stake in good theology and good engineering is we don't all agree on which is good. Certainly not everyone in this room will agree as to what form church government should be. Yet I've heard people of all different denominations say, I believe this because the Bible says this. And other people will say the same thing about a different form of church government. Another aspect is people don't agree on what's good engineering. And I don't just mean good engineering versus sloppy engineering. Let me amplify the example that I have here. You could design something so it's easy to make, or if it's something like an automobile, you could design so it's easy to repair. Those two will result in very different designs. I had a minivan about 10 years ago that was clearly designed to be manufactured easily, and to repair some of the things on the engine, they had to open up the cab area where the driver sit and remove some stuff to get at the engine that way, because they couldn't get at it from opening up the hood. So the point is, that was designed to make it cheap and easy to make, but it was terrible to repair. If you made it easier to repair, it may have cost more money. So there are some trade-offs. But again, what is good engineering? What is good engineering in this situation? You have to decide whether you like manufacturing ease and low cost, or whether you like repairability ease. And there's lots of other engineering situations where what is good engineering is itself something people would differ on. So it's not just good engineering versus sloppy engineering. It's what is your goal when you're doing the engineering. An example of that is innovations. We certainly need innovations in theology within certain constraints, and we need innovations in engineering and technology. But in both cases, what's developed must work with the reality that we already have here. You know, a good theologian needs to help Christians face new issues. We have issues of privacy with the modern technology that we did not have before. An example, I'm involved with political activities. The various candidates in most states can look you up and find out your address, your name, what party primaries you voted in, and which ones you voted in, so they can target the people who go all the time, or not waste money on people who don't. And they could also find out your age from your voting records. They could also, based on where you live, have a pretty good estimate of your family income. So the politicians running for office this year know a great deal about you if you are a regular voter. Did that bother you? Maybe it does, maybe it doesn't. But the point is, we have a pervasive technology. Now, there are some things we cannot escape. If I want to buy an airplane ticket, I have to give my credit card or debit card, and that reveals information about it. But an example for me in privacy is, other than things like hotels, rental cars, and airplane rides, I personally do a cash economy. And so many stores will say, "What's your phone number?" And I will say no to that answer. You know, if I'm using a credit card, they have a right to know things, but otherwise, I don't think they do. But the issue of how we should respond to technology and privacy is something we need help from theologians. However, too much innovation in theology can lead to models about God that do not match the experiences of Christians throughout history, leading to what I would say to be heresy. There are certainly many cult groups in the last 150 years that have been developed because they had, in their opinion, new insights. But those new insights were not consistent with the old insights we have in the Bible. Engineering innovations are important too. And engineers are frequently rewarded for creating new designs. However, what you create must still work in the real world. Something I've become more and more concerned about is our innovations must be sustainable in the long run too. You know, that if we deplete resources too rapidly, that's a real problem. And the point is, not everything that can be made should be made. And I'm not even going to get into the issue of who decides what should be made. But the point is, I think we would all agree there are some things not worth making because of their consequences. So I want to look at an application where I would say an approximate model of theology can be used to give insight into the approximate models of engineering. And excuse me, this is a problem faced by engineering education and theology. And it relates to relativism. I'm not talking about the relativism of Einstein, but the relativism of a perspective that there aren't absolutes. It's being promoted as part of a good way to teach engineering. Some are doing this without realizing its significance, I'm convinced, because most engineers are not very philosophical. However, I think some very well do recognize why they're doing it, and are doing it deliberately. So let me tell you a 20-year-old story that has modern implications of a paper I saw this last week. In 1990, Richard Colbert did a paper about engineering freshman education. And he applied William Perry's model of intellectual development. Perry had positions or stages of development ranging from the lowest level, where all knowledge is known, to the highest level of commitment to something within relativism. His university, which was my former university that I graduated from, based their new freshman and sophomore introduction to engineering on this model. They noted that a lack of a unique solution to engineering design fits in well with Perry's view that intellectual maturity involves a commitment, I should have said, to be within a relativistic worldview. I knew this professor many years ago when he was a professor and I was a student at the College School of Mines. He's a very nice guy. I don't think he really understands the significance of what he's done. I think some of the other people who followed him do. I think he doesn't really understand that whole significance. But it's not just an issue about design education. It's the way we teach all of our classes. There's been a lot of educational reform in the world of engineering in the last 10 or 15 years because our lecture method we've traditionally done don't work with many of our students. So we need to try something different. A variety of strategies that go under the names of active learning or collaborative learning are being adapted in engineering classrooms. Active learning concepts are not new. They've been around college of education circles for a very long time. They've been around engineering circles for some time under a different name. We call them labs. But what's different is that people are beginning to put that into the traditional classroom, not just into the separate laboratory experience. So some examples are doing experiments within the lab and use them to teach the material. Another one is break the class into smaller groups at various points, have them solve a problem based on new content, or have groups report on what they've studied at the next class period instead of traditional homework. And I've tried and used all three of these at various points. The issue at stake is these are based upon what's commonly called a constructivist approach. And this paper in the Journal of Chemical Education, notice the name, it's an engineering journal. They say traditional theories assume our mind can take images that somehow represent reality, as if they were copies or pictures. If one accepts this assumption, knowledge can be judged as true or false. Constructivist theories of knowledge are based on a fundamentally different assumption. Knowledge is constructed in the mind of the learner. From the perspective of the constructivist, knowledge should no longer be judged in terms of whether or not it is true or false, but in terms of whether it works. The only thing that matters is whether the knowledge we construct functions satisfactorily in the context in which it arises. So we construct knowledge. If it works to our satisfaction and we feel good about it, it's fine. This does appeal to a lot of engineers who are used to thinking of what works. Most engineers are in practice utilitarian. However, what works in a class setting may not work at all in actual engineering design. Because if you have a group that gets together and you go over a problem and then you feel really good about it, does that mean you solved the problem? Maybe, but maybe not. You may feel real good about the wrong answer.
Did you get a trophy?
Yeah. So one of the issues is, I think as a Christian and engineer, there are some things that are true about our world, some things that are not true, but students may construct a reality that is not true. However, they may firmly believe their false reality is as good as the true reality. I saw this earlier this week. On Tuesday morning at the American Society for Engineering Education annual meeting in San Antonio, there were two papers presented in the ethics division where they've done surveys at two different universities. I won't embarrass them by saying which ones. And they found that 75% of the engineering students use online solution manuals to solve homework problems, even though they've been explicitly told not to do so. However, a majority of those students claim they have never cheated in any class. Now, I saw the same result with Baylor students 5 years ago and Louisiana Tech students 10 years ago. And at first I thought they were being hypocritical, but I don't think that's the issue. What's happened is they have constructed their own version of ethics, and then they are obeying their own version of ethics, irrespective of how the professor might have defined it. They have constructed an ethical perspective that we would say as faculty is at odds with reality. Now the question is there anything good about constructivism? Well, there is some. This is how many engineers really do research. We create models to explain our experimental results. Education faculty might say we are constructing our own reality. I think, and I've had some say that to me. I think that may be an overstatement. So the question is, should I throw out active learning because it's based on a philosophy that I don't like? Well, I think we need to do a little more thinking. When we use active learning, we need to emphasize to the students, we're not going to tell you the answer to this statics problem or this strength problem, but we're going to assert to you that there is an answer that exists. So for many engineering calculations, there is only one correct answer and everything else is incorrect. Students need to recognize they do not have the right to construct an alternative reality that does not fit the reality of the world we're in. We still have a problem, however, with design in that there's no single right or true answer to a design problem. This does not mean that any answer is acceptable, because while there are several right answers, there are many wrong answers. An example, if the question was to design a chair, there are many possible good designs. However, if one of those chairs tipped over, that's probably a problem for you. If it just breaks when you sit in it, it's a problem. So the fact that there's not a unique answer doesn't mean there are not unacceptable answers, because clearly there are. So many active learning techniques do appear to work, but they're based on constructivism. So should we use them? Well, what I thought we ought to do is look at, is there any biblical support for these? If so, the fact that it's been rediscovered by modern constructivists shouldn't be a problem. So we find in the Old Testament, he talked about these commandments I give you today are to be upon your hearts, and press them on your children. Talk about them when you sit at home and when you walk along the road, when you lie down and when you get up. The idea that teaching is part of ordinary life with physical illustration. Okay, Jesus talked about used common things. When he was asked, should you pay taxes to Caesar, he had them bring out a coin and looked at the coin and gave his famous answer. But the idea is he was using things around him as illustrations. He was not just lecturing to them. He also used questions and answers. People asked him, by what authority are you doing these things? And then he said, well, let me ask you a question. Was John's baptism from heaven or from men? And they were afraid to answer him. So Jesus said, neither will I tell you by what authority I'm doing these things. But the point is, this question and answer interaction was not traditional lecturing by any means. There's a lot of other biblical examples of active learning. We teach a lot of things by symbolic events, whether it's Passover or communion or baptism. Those are in many ways all very active learning activities. So my point is that while there are professors trying to introduce relativistic thinking into engineering education through active learning and engineering design, we need to recognize that things like this are inevitably going to happen because engineering is an approximation and people always have new ideas about how to do this approximation. But I think even though theology is an approximation, we can use it to help make judgments concerning engineering. This particular example, I still have real concerns about the whole constructivist approach and about the idea of constructing the reality and feeling good about it, whether it's really true or not. But I do think that because active learning was used in the Old Testament and the New Testament, we can say the constructivists rediscovered what happened in the Bible, even though they didn't realize that. So I don't have a problem with some of the techniques of active learning, recognizing what its fundamental basis is. So the point is that both theology and engineering are approximations to reality, not ultimate reality itself. But they both can become good enough you can reliably use both of them to guide your life. Any questions? Okay, over here, you had the first question.
It's kind of a two-parter, I guess. Do you think that the world as Christ encountered it, the rabbinic pharisaical thought was constructivist and came to cheated theology?
You can certainly cheat in a theology class.
Yes.
I've seen that done.
Yes.
Cheat at theology, I'm not sure of that. I guess if you create a theology that bears no relationship to the way Christians have understood it, I mean, I would say if you create a theology that bears no relation to the Bible, from my perspective, I don't know if you'd call that cheating, but I would certainly call that
Misleading.
Misleading, yes.
What about the constructive? Do you think the rabbinic pharisaical interpretation of the Old Testament?
To some extent, because they took the Old Testament law and then added in all these other things to amplify.
Nice to think about.
Yes. On the other hand, certainly any good pastor will amplify what's in the text to make it relevant. So there may not be a fine line, but I think at some point you cross the line. It may be hard to define exactly where that is. Yes.
So I think there is some degree to which there is a valid constructivism in engineering. For example, if you think about the a plug in a wall. That's not that's a bit of a constructed idea, and so to some extent, do you think the design space might have some constructivist element to it?
Well, I think there's a difference between constructing things, which engineers do all the time, and a constructivist approach, which says we are creating our own knowledge. I mean, to some extent, research is creating new knowledge, but I don't know that I would necessarily go as far as you've implied there. Yes?
This is similar to the question I asked Walter Bradley, but do you have any thoughts on whether intelligent design changes how engineering is done?
It hasn't changed how I do it, and I know it's changed how some people do it, but I don't know how general that is.
Let me just comment. I think biomimicry, if you know what that is, it's observing things in nature like honeycomb structures and so forth, which we're often mimicking what we see in nature for really clever ideas that we might not have thought of at those pictures. So I think there is sometimes a place where we learn. The early airplanes were designed by looking at bird wings.
So I would agree with that aspect of it, certainly. Other questions? Okay, well, thank you very much. I'm sorry about my coffee, and I hope I get over my allergy attack soon.